All right, everybody. This is how we're doing it. Click this link, open this up. If you can't do it, don't worry about it. It looks something like this. All right. Yeah, we're going to get rolling here. Here's the questions we're going to go over. How do greenhouse gases affect the climate? So if I go like this, what's the temperature like? 57, 56. Okay. Now, if I'm going to pump up the greenhouse gases all the way up to a lot, you're going to see it's a lot hazier. It's kind of like the city, living in the city when it's humid in the summertime. Just hazy. All right. Oh, dang. Look what happened to the temperature. We increased the greenhouse gases and they're going up. It's getting hot in here, so keep on all your clothes. Yep, a little bit of Nelly song. There's 63, 64. Okay. 65. It's like the greenhouse gases trapping the heat. They're almost like a blanket. All right. Let's move on with this. We're going to drop this thing like my mixtape. So the greenhouse gases are gone. You see it's a lot clearer. All right. You'll see these yellow photons, which are the sunlight. They come down. And you'll see the red photons, infrared, which are like the heat. And they're just being absorbed, but then like kind of like slowly escaping. Speaking of escaping, look at the heat, man. This thing is dropping like my mixtape. It's down to like 8 degrees. 4 degrees, 3, 2, 1. Dang, it's like 0 brick right now. All right. So yeah, greenhouse gases without them, it's cold, real cold. All right. So into this, how do greenhouse gases affect the climate? They trap in heat. A little is good, too much is not good. How is the ice age different than today? So let's take a look at this. We click on today. All right. All right. So look at the greenhouse gases here. Carbon dioxide, CO2, 388. CH4, which is methane, 1.843 parts per million. Nitrogen oxide, N2O, 0.317. All right. Also, too, you see how the temperature here, it's climbing up. Now, if I put it on the ice age, I'm sorry, well, the temperature, it's getting warmer. I shouldn't say it's like rocket high, but it's getting there. All right. Now, let's click on the ice age. Goodbye, grass. Goodbye, green fields. Now you just got snow-covered plains. Looks like a movie from Frozen. All right, look at the greenhouse gases. You see how they went down in concentration? 180, 0.38 for methane. Nitrogen oxide is 0.215. So, yep, that's what happens during the ice age. So, yep. You see how the temperature be dropping a little bit too. All right, not a ton, but you can see it's like 38, 37, 36, 35, 34. All right. It's going to continue dropping. All right. We're going to move on though. What happens when you add clouds? Ooh, so let's bring it back to today for a second. And then let's pump up these clouds. Let's put some pretty clouds there. 3 clouds. Now with these 3 clouds, you see the temperatures like was 37, 38, something like that. You'll see some of these yellow sunlights go through and some of them rebound. Yep, like that guy right there. Rebounded. Yep. Oh, rebound. Good. That guy went through. All right. Now, the sunlight rebounds, but the infrared photons also rebound. You'll see how, like, let's see if I can get one here. Let's follow this guy up. These 3 here. Boom, rebounds. So the clouds act just to trap in the heat and also block out sunlight, though. So they kind of are an insulating factor. They kind of just keep it the way it is. That's why when it's a cloudy day, it's just humid. Just crazy stuff with my hair. Just makes it all curly and stuff. All right. What happens? Change the greenhouse gas concentration. See how the temperature changes. So for this, again, this is the greenhouse gas concentration right here. Let's get rid of these clouds. So you know what happens when we change it like that versus changing it like that. Lots of greenhouse gases. Hey, temperature goes up. Drop in the greenhouse gases. Hey, temperature goes down. So, yep, that's what we got. All right. Next question. What happens when you add a glass pane? That one, what we're going to do is click on this right here. Glass pane. Oh. So you see the temperature, it's like -13, -15. Dang, that thing is cold. All right. We're going to hit view all photons too. So you see all the sunlight coming down. Starting to see that red just radiate back up, but it's leaving. All right. All right. Glass panes right here. You'll see how the yellow sunlight goes through all the glass panes. But you'll see how, like, a lot of the reds, they get rebounded and they get trapped. So look at the temperature. It went from like -15 and now it's skyrocketing. So again, all the sunlight comes through, but then the red photons, they get trapped in here. And that's why they call it the greenhouse effect, because this is how a greenhouse operates. A layer of glass, layer of glass, layer of glass, and all that heat gets trapped inside. So, next question. Oh, wait, let's see the temperature of this. It gets up to like 113. All right, 115 even, 120. Dang, it's skyrocketing. All right. So what happens when you what's this one? For photo absorption, how do visible and infrared photons interact with different molecules? All right. So go into this. We're going to click on visible photon first. This is the sunlight. And we're going to turn this cannon on by turning that to there. You see how, like, the visible photon, it goes right through this molecule, which is methane, CH4. It goes right through CO2, which is carbon dioxide. It goes through H2O, which is water in the form of steam. It goes through nitrogen. Yep. And it goes through, like, oxygen. All right. It goes through all of them. All right. Sunlight goes right through. Yep. Does not stop. It's like you at the school bus, man. It's like, woo, straight to the bus. All right. Now, grab that seat before the sixth graders do. Now, you hit the infrared photon here. It still goes through oxygen. Yeah, no problem. It still goes through nitrogen. No problem. Water. All right. Oh, wait a minute. Water's starting to dance. Man, it's like some of you in front of a TikTok camera. It's like, woohoo, little jiggle, little wiggle, little dance, little dance. All right. So the reason why water is dancing is because it's absorbing that infrared photon and then it's releasing it off in another direction. So it's like trapping it basically in the atmosphere. So water is a greenhouse gas that does trap heat. Carbon dioxide. Oh my gosh. Yep, carbon dioxide. Dancing, dancing. Yep. All right. Carbon dioxide is absorbing that infrared photon as well and keeping the heat and then just shooting it off wherever. Methane here. Yep. Methane is dancing, getting down. All right. It's got its little two-step going on. So yeah, infrared photons, it absorbs some and then it shoots it off to the side and then shoots it off to the side. So it holds on to heat as well. All right. Do all atmospheric gases contribute to the greenhouse effect? No. You'll see how, like, these ones right here, CH4, CO2, H2O, they all dancing. They contribute to the greenhouse effect. Nitrogen, no dancing. Oxygen, no dancing. It's like a boring person at a wedding. They don't move. They don't dance. All right. Describe the effects of greenhouse gases on photons and temperature. So for this one, the photons go right through. Infrared, invisible. All right. But up here, carbon dioxide, and this is for like carbon dioxide, the methane, the H2O. It holds on to that infrared photon and then it just holds on to the heat. So, effect of greenhouse gases on photons and temperature. Yep, increase the temperature. Describe the effects of clouds on photons and temperature. So, back to this one. Greenhouse effect. Come on now. Up them clouds. Clouds activate like a blanket. They just trap in heat. It's an insulation factor, but they also block out sunlight. All right. So they keep the temperature kind of regulated. All right. And they bounce photons off. Compare the effects of greenhouse gases to the effects of glass panes. They're kind of alike. So you see here, This is like a greenhouse gas. It traps in the heat. It's like what that car thing we were talking about, how you got the windows up in the sun. It acts like an oven. So, yep, keeps in the heat. Describe the interaction of photons with atmospheric gases. Um, they dance. Okay. So, visible photons go through all the molecules. All right. Infrared photons get absorbed by CH4, CO2, H2O, but not by nitrogen or oxygen. And explain why greenhouse gases affect temperature. Greenhouse gases, they basically act like a blanket. They don't create heat, they just trap it in. And a little bit is good because you don't want to enter an ice age and have all of our food sources die. But you don't, the problem we have right now is that we just have too much greenhouse gases and they just causing the planet to warm up too much. So, hope this helps. Adios.